Okay, let's talk about the second derivative. So we got two exercises dealing with the second derivative on Khan Academy. One is just entitled Second Derivatives, and the other one is Second Derivatives with Implicit Differentiation. Both of them want you to do the same thing. Take the derivative and then take it again. It's just that one of them is already kind of solved for y, so we can just go ahead and take the derivative of the expression using the power rule, product rule, quotient rule, or chain rule. And the second one is a jumbled expression with y's that are not easy to isolate, and so we will have to use implicit differentiation for that. We already know how to do the derivative, so I'm just going to work you through these problems to give you an example of how Khan Academy wants it to be done. C is not necessarily the answer, that's just a random touch. But here, d squared over dx squared is the dy over dx notation for the second derivative. We don't have the y, where is it? There, here, because there's no y in the expression. But basically, this part here, d squared over dx squared, is just telling me to take the second derivative. There's a reason we didn't use this notation in class, because it's confusing, but it is the more formal notation, which is why I think Khan Academy is using it. But we can ignore it. Really, all we have to do is take the second derivative of 10 over 3x to the third. Okay? So we just want to take the second derivative of that. I don't want to take the second derivative in that form, though, so I'm going to change it to a power form so it is easier to work with. Change. I'm just going to move the variable up with a negative exponent so that now I can rewrite it as 10 thirds x to the negative 3 power. So then I take my first derivative. I'm going to split over to our prime notation to kind of show that. So f prime, we can just use the power rule. So I'm going to bring the negative 3 down, multiply it to the 10 thirds, and I'll show that. So negative 3 comes down. We multiply that to the 10 thirds, and then x to the negative 3, and we just take away 1. So subtract 1 from the power, which means this is now negative 10 x to the negative 4 power if we reduce it, or negative 10 over x to the 4th. But we're not done. It wants me to find the second derivative, so I just do it again. Okay. Same thing, power rule, product rule, chain rule, or quotient rule. Nothing there changes, with the simplification step in the middle, just like we did here. So now we're going to take f double prime, and we can keep going. We take the third derivative, the fourth derivative, the fifth derivative, keep going, finding the rates of change as we go for the functions. But okay, writing it out, we would bring the exponent down, so that negative 4 comes down, multiply that, negative 10, to the coefficient, and then we would add x to the negative 4 minus 1, which would be 40 x to the negative 5 power. So 40x to the negative 5 power, which we look isn't there. But that's because, notice at the very beginning, we changed the form. Expressions have lots of different forms that they can be presented in. In this case, that negative exponent makes it very easy to take the derivative, but it may not be the form represented in the multiple choices. So we have to look for an equivalent form, which in this case would be a 40 over x to the 5th, using the same method of changing this as we did here, taking the exponent, moving it across the fraction bar to change its sign. So for this one, we want to choose option A, 40 over x to the 5th. Here, get it? So we have h of x is equal to 2 to the x. So we have an exponential function. This isn't going to be power rule, product rule, quotient rule, or chain rule. Rather, it's just a common derivative, so it's one that we're expected to know. So it wants us to find the second derivative, h double prime. To do that, I have to go through the derivative. It's a sequence. So original function, first derivative, second derivative, third derivative. H prime of x. Okay. Remember, this is just like e to the x. So its derivative is exactly the same, 2 to the x, but we also have to multiply it by the natural log of that base 2. So that's your first derivative, 2 to the x and the natural log of 2. Now, this is where I think a lot of people get stumped by these, because that natural log 2, but that is not a function, it's a constant. The natural log of 2 can be evaluated on the calculator, and so we really just get to ignore it when we take the second derivative. Our function is 2 to the x, so we're going to differentiate that, and then we're just going to multiply by that natural log of 2 again, which is 2 to the x times the natural log of 2, and then we bring down this natural log of 2 times the natural log of 2. Which, if we write it a little bit nicer, is 2 to the x times the natural log of 2 squared. And so that's exactly how we have to type that in to here, if I can do it. So we got 2 to the x power times, and then we'll do the natural log of 2 squared, but I'm going to put that in parentheses. The natural log of 2, and then put the squared there, like that. Now, making sure that I get that correct so that the computer recognizes it as correct is difficult. Back in college, we had computer quizzes like this. And you had to be right. You had to put it in so the computer recognized, because it doesn't know what you're putting in. It's just checking it to see, does that match the string, the answer that I have in the database. And for one of the problems, the teacher, I don't know what he was thinking, made a typo or something, and we had to take pi out to 13 decimal places in the calculation to get it right. Yeah? So, if you understand the concept, you understand how this is working, and you're getting it wrong, but when you go to the get help and everything is the same as what you did, you're good. Just move on. All I'm looking for is that you attempted the work. And that'll show me that it'll give you a grade. It'll say completed, and your grade might be a 0, but you'll still get credit for it. Make sure you understand the concepts, though. And the tests, which are on Google Classroom, are actually a little bit easier than what you see on Khan Academy. Because again, I'm just looking for that concept. We'll let AP Calculus hit you with the harder stuff, the ones that you have to actually think more through. We just want to build those concepts. So, if you understand the concept, again, the take-home message here, if you got the concept, you're good. Don't worry so much necessarily about getting 100. You're fine. I've seen what you guys can do. We're not really trying to move into new stuff here. This is all familiar stuff, either from the beginning of the year or the middle of the year that we're just reviewing. So if you're good with the concept, we're good. Just focus on the tests that are going to be on Google Classroom and the great calculus caper, and really just getting through the assignments with understanding. I'll just blow through them, but I don't want you to worry too much. If you're entering the answer, now the multiple choice ones, you should be able to get correct. But the free response, especially with calculus, it can be hard to get the perfect form that the computer is going to mark correct. So if you're struggling with that, just get it and move on. Okay? But speaking of moving on, let's check. So in this case, yeah, we did. I got it correct, 2 to the x times natural log 2 squared. But again, I imagine if I wrote it like that, it probably would have marked it wrong. Even though it is correct, it's just not the form it had in its computer. But it's not fully simplified either. All right, I digress. So, same hint, they've switched back to the dy over dx notation. So we have d squared y over dx squared. Really just means take the second derivative, and we have y equals 6 over x squared. Same problem here. That's not a very easy form to take the derivative in. I could use quotient rule, but that's a mess. So we're going to change the form into power 4, making this 6x to the negative 2 power. And then again, I'm going to go through my derivative, bringing the exponent down. So our first derivative, y prime. Well, let's do it like this. So dy over dx. Let's use their notation. I would bring the exponent down, so negative 2 times 6 is negative 12. And then subtract 1, negative 2 minus 1 is negative 3. So that's my first derivative. Now, if they wanted the first derivative, I would probably rewrite this as negative 12 over x to the third, since I would be doing algebra after that. But since they want the second derivative, I'm going to leave it like this. There's no simplification that I can do, and then just go to the second derivative, which would be d squared y over dx squared, which is the second derivative with respect to x. And then we just do the same thing. We're taking the derivative. It's a power form, so we're going to use power rule. I bring that down. Negative 12 times negative 3 is 36. And x to the negative 4, negative 3 minus 1. I look at my answers. There isn't one there. There's a natural log there. But this, I know, is equivalent to 36 over x to the 4th. And that form is one of my answer choices. It's B. So we choose that one. Last one on the second derivatives, just to give you an idea. I'm going to move through this one fairly quickly. So we start out with f of x is equal to 2x plus 1 to the 5th. First thing I do is look for simplification. I know I'm taking the derivative, so I could expand this 2x plus 1 to the 5th power by the binomial theorem, which is 1, 5, 10, 10, 5, 1. So I could get 2x, so 2 to the 5th power, 32x to the 5th, and all that. But I'm not going to. I'm not going to. Because chain rule works just as well, and it's quicker and easier. Now, we do have to go to the second derivative, so that could cause problems. But one step at a time. Let's get the first derivative here taken care of. F prime of x. That's chain rule. My outside function is x to the 5th. My inside function is 2x plus 1, so that's going to work out as 5 times 2x plus 1 to the 4th power times 2. Okay. And that's, again, chain rule. F prime at g times the derivative of g, or the outer function's derivative with the inner function plugged in, times the derivative of the inner function. And you can see that that's what we did. If we did f as x to the 5th and g as 2x plus 1, then f prime would have been 5x to the 4th, g prime is 2. And if we did f prime at g, so f prime at g times the derivative of g, that's what we get. And then look for simplification. A big deal in math is simplifying as you go so that your work doesn't get overly complex. This, we can do the 5 and the 2, would be 10 times 2x plus 1 to the fourth power. That would be my simplified first derivative. And then the second derivative here is going to work just like that. It's really the same type of function. It's going to be chain rule again. But we can use what's called the modified power rule for chain rule here. So the power comes down. 4 times 10 is 40. And then we would have the 2x plus 1 to the third power, and then just times 2. And then simplifying, that would be 80 times 2x plus 1 to the third power as my second derivative. That's going to be my answer. So that's what I'm going to plug in right here. $80 times 2x plus 1 to the third power. And check our answer there, and that should be correct. Hooray! Right. Now, there it is. Pen has a little bit of lag on it. Let's look at second derivatives with implicit differentiation. If I can get to it. Is that it? There it is. Okay. Okay. So same idea. We want to take the second derivative, but now we've got expressions with y in them as well, which means when we take the derivative of this sine y, we're going to get a y prime as well. So let's see what this works out as. First, dy dx is equal to the sine of y over x. We want d squared y over dx squared. They're not telling me the original function. They're starting out by giving me the first derivative. dy over dx is y prime. Y prime is equal to sine y over x. So we only need to differentiate once to get to our second derivative. So let's look at that. This is going to be quotient rule, unfortunately. So low d high minus high d low over low squared. So we're going to go low d high, so x times the derivative of the sine of y. Derivative of sine is cosine. So we get cosine of y, y prime, minus high d low, which is just going to be the sine of y over low squared. So x squared. That is d squared y over dx squared. But we have an issue. A couple issues, really. But our first issue is this y prime here shouldn't be there. We don't want our derivatives in our derivatives. That's redundant. And we might want to clean this up a little bit if we can. So we're going to do some substitution of that. We're going to put sine y over x right in there. So here's the fun part. Here's where the algebra comes in. So we're going to replace y prime. So we have x times the cosine of y times the sine of y over x minus the sine of y all over x squared. Now technically that is an expression for the second derivative. But I'm fairly certain that if I try to put that in here, I'll probably type it in wrong for one, but it's not going to match what the computer has stored, what the computer is going to look for, even though it is a correct expression. So we've got to do some simplification. Couple things here. This x will cancel that x. So now we would just have cosine y times sine y minus the sine of y over x squared. And I'm going to simplify that a little bit farther as well, factoring out our common factor of sine y times, now we would have cosine y minus 1, and all of that over x squared. And that's going to be my second derivative. Now that takes time. You're going to be patient and just kind of slowly work your way down, especially with the trig in there. But let's see if we can then type that in. There. So first thing I know, it's a fraction. So I'm going to put the fraction in first. And then the top is sine of y. And we're going to put a parentheses. Cosine of y minus 1. And then on the bottom, we just need the x squared. Now, I don't know if it needs the parentheses. It shouldn't need the parentheses in the cosine, but we'll see if it checks this off correctly. Which it did. But again, if I make a mistake typing this in, if I put a space somewhere there's not supposed to be a space or anything, if that's a dash instead of a minus, the computer might mark it wrong even though you didn't do anything wrong. The computer is not infallible. It's pretty good, and we've gotten really good at recognizing math, but it's still just looking at your answer and looking at a database and seeing if they match. So if you have the concept, if you understand what is happening here, but you're struggling with entering it into the computer, you are okay. You don't need to keep trying to match what the computer wants you to do. Get the concepts and move on. Do a couple more. So this one, you might need a calculator. Y to the fourth minus 2x equals 5. We want to know the value of the second derivative, so that's y double prime, at the point negative 2, 1. Which means first, I have to find the second derivative. Then, I will plug in x is negative 2, y is 1. So let's start there. Y to the fourth minus 2x is equal to 5. And if we kind of think this through, if I want to know the second derivative, I have to know the first derivative. So start there. Let's take the first derivative. I don't want to take the fourth root of an expression, so I'm not going to try to solve for y. I'm just going to work it through implicitly, which just means term by term. So this y to the fourth would become 4y to the third y prime. I'd do it just like power rule, but because it's not the variable that we are taking respect to the variable on the bottom of this derivative, we put that y prime. Minus 2x is just minus 2 and then equals 0. So that's our first derivative. Well, technically, this is our first derivative, but we have differentiated one time, and so that first derivative should appear in our expression, and we can solve for it. We can solve for this very easily, in fact. Y prime is equal to 2 over 4y to the third, which can reduce even farther to 1 over 2y to the third. So our first derivative is 1 over 2y to the third. This is very easy now to get to the second derivative, because like we did before, I can change this form. It's 1 over 2y to the negative 3. And then we're going to differentiate that by power rule. So y double prime is equal to, bring the negative 3 down, so it's going to be negative 3 halves, y to the negative 4, y prime, that's our second derivative. Now I can start plugging in values. We know y is 1. So y double prime is negative 3 halves times 1 to the negative 4 power, and then y prime. I need to know the value of y prime. So I go back up here. Y prime is 1 over 2y to the negative 3 power. If I plug 1 into there, for y, I get 1/2. Now I can find the value of y double prime. It's negative 3 halves times 1/2. That's going to be negative 3/4. Notice, I took my expression. I decided I don't want to try to solve for y. I'm just going to differentiate implicitly, so I did that. 4xy cubed minus 2 equals 0. I solved for the first derivative, and because I knew I was going to be taking the derivative again, I simplified and then changed the form to one that is easier to take the derivative of, a power form. That got me my second derivative, negative 3 halves y to the negative 4 times y prime. And because they wanted a specific value at a point, I used the ordered pair, an x and a y, to replace the y value in the second derivative and also to replace the y value in the first derivative, so that I had the second derivative equal to a value, in this case negative 3/4, which tells me the acceleration of whatever is tracing out this function at that point. Second derivative, acceleration. So we're going to put that in here. That is what? Negative 3/4. Negative 3 over 4. There we go. We are given the first derivative. So in this case, dy over dx, which is the same as saying y prime, is equal to x squared minus 2y. So be careful. They're giving you the first derivative and then asking you about the second derivative. So we only have to differentiate once for this problem. So we need to find d squared y over dx squared, which is y double prime, which in this case is 2x minus 2y prime. Okay. But I don't want to put that down. I don't want 2x minus 2y prime in there. I want to replace that y prime with this, so that I have y prime in terms of just my original variables x and y. So that's what we're going to do. Y double prime is equal to 2x minus 2, and then that expression for y prime, x squared minus 2y. We could leave it like that, but I'm actually going to FOIL it out so it's just term by term. So we have 2x minus 2x squared plus 2y. And then I'll probably reorder it too when I type it in here. But that's going to be our answer. That's it. Working our way down, taking derivatives. So it is negative 2x squared plus 2x plus 2y plus 2x plus 2y. Check real quick, make sure that what I've typed in matches what I got as an answer. And then check again. So it's saying we made a mistake somewhere. Well, let's see. Why? No, I just want to hit. Let's see what's going on. Didn't have a get help. Check it. There it is. Now, again, see. Oh, well, couple of things. One, they didn't change the order, and two times 2 is 4. But again, simple mistake. Doesn't mean I don't know how to do this problem. It means I don't know how to multiply 2 times 2, apparently. It's 4. That should be a 4y. But I have the concept. I made a simple arithmetic mistake, which we're all fairly used to anyway. And it's easily correctable. I just go back, put the 4y. Oh, okay, there's my mistake. Let me go correct that. Now I gotta scroll all the way back up. Again, if you're struggling, this does work you through the problem as well. So the Get Help is a nice resource, but you go, oh, that shouldn't be a 2y, that should be a 4y. And now when I check it, it should give me that correct answer. There we go. Now, it doesn't mark it correct. It's still going to be grayed out. I didn't get it on my first try. But I got it eventually. I don't need to go back and work this whole practice unit unless I didn't really understand what was going on. This one is the same as number 2. So work your way. You have the original expression, find the second derivative, and then plug in your x and y coordinates as needed. All right, guys. That is for second derivatives and second derivatives with implicit equations. We are almost, I think the interpreted motion graphs I'll do a video on, and then we're on the integrals. Again, everything that's on Khan Academy, that's the last I'm going to post there. And on Google Classroom, you have the derivative test up. You have that great calculus caper up. And I'm going to post the integrals test today, as well as I'm going to try to get these separable differential equations, which is actually really simple. And that's it. Once that's all done, you are done. Okay. So keep up the good work. Hope everybody stayed safe. We'll see you next time.